think that's fine. So first of all, thank you so much, everyone, for being here. I hope you enjoyed the long workshop yesterday and all the presentations today, but let's maybe quickly get to it. The session today is about open source energy planning, and I would like to highlight a few points that would start with the value proposition of open source software, especially in energy planning, and then a little bit of a brief on how does open source ecosystem work, especially in our case in Pipesa meets Earth, and how do we deal with such a big model like Pipesa Earth. And then highlight some differences between open source software like Pipesa and other proprietary software. What are the differences and challenges and so on? Actually, the second or the next point would be focusing on the challenges that we have seen over the past few years when it comes to using open source software in energy planning. And finally, some discussion and some questions I have to you. But maybe we can keep this after Anna's presentation as you see fit, Daniela. Could you please go to the next slide? Thank you. So what is the problem with proprietary energy planning software in general? So proprietary software, as with, for example, Microsoft Word, it is a proprietary tool that does a good job, and you usually have very good support, but it comes at a licensing fee, and you do not have the freedom to add a new feature, for example, in your Microsoft Word, right? So similarly, in energy planning, proprietary tools, they do a good job. They are, as of now, take the lion's share in all the planning activities you see in different countries of the world. However, they also come with some shortcomings. First of all, they come at a license fee, so you have to pay for the use of the model. They do, as I said, fulfill most needs that the energy planners would want. They come with good support, and they are widely known. And a tool widely known is usually a tool that is people are confident in its features. However, there are some shortcomings. If you can press one, Daniela, that's an interactive presentation, and a lot of animation, so I'd have to do that. First thing is the customization. So it's not easy to add a new feature to such a tool. You'd probably have to issue a ticket, ask for it, and then wait for the vendor to add this feature if they think it's suitable in general. Could you go next? For example, is collaboration. You are always able to use the tool, but you're not able to develop it. That's different, of course, in open source, as we can, most of you have already seen, whether in Pipesa tools or other open source tools, you can always add your own features that fits your specific application. Back to the shortcomings, there's usually problems with affordability, and we've seen this in many cases in developing countries, for which these licenses are usually coming from some sort of foreign aid or as grants. And this limits, for example, adapting these studies as the environment changes. So with new political decisions or there are political shifts, usually the country's plans change, and that usually requires rerunning such big models. And just rerunning that usually also costs more money. So it's for example, in the well-known energy planning softwares, as much as I know, the licenses could go above 100,000 US dollars. Transparency, of course, that's one of the big points for open source, that one can easily check how this model works. If they would like to challenge results from a study, they can easily say, okay, we think that this is not executed in the right way. You can do it better in another way, and hence increase the credibility of the study. Digital sovereignty, which doesn't exist in case of proprietary tools, just because if there happened to be a sanction on a country that provides the tool, this could use or could lead to a blackout effect, in the sense that an organization or an institute could no longer have access to that specific tool. So what we're trying to say is that open source gives you more freedom. It gives you more freedom to share and distribute and modify the software, which takes you from the figure on the left to the figure on the right. Basically, on the left, this means that every institute builds its energy planning software from the ground up. So it builds everything on its own, including the strategic value added or the specific application. However, if they use open source tools, they could share a foundation in which they could build together something that we have, for example, done within Pipes to Earth. I'll come to that in the next slides. But they could share the burden of building this foundation, and then each institution could add their own strategic value. For example, one institution is focused on hydrogen applications. They could tailor the tool towards hydrogen applications. One other institution is more focused in countries in Latin America, for example, so they could even tailor the model more, add more features to fit their applications, and so on. We can go to the next slide. Thank you. So yeah, just to put it into some words, this digital collaboration usually reduces the individual cost on the institutions and accelerates innovation. It ensures the long-term maintainability, or I would say maintenance, sorry for that, because it's a shared foundation. For example, in Pipes to Earth, we now are 4 institutions maintaining the main base foundation. So if at one point one of these institutions say that, okay, we don't want to use this tool anymore, there are still 3 other institutions that help maintain this tool and make sure that there is some long-term viability of the product. And finally, again, this just increases the digital sovereignty and freedom to customize. If you please go to the next slide, Daniela, thank you. This is, of course, happening in many other sectors. Just to name a few, things like phones, cars, cloud computing, even nuclear and submarines, something I knew recently, use open source at some degree. For example, on the right, you could see that applications like Samsung phones or Pixel or even Kindle, they do have a shared foundation, starting from the Linux kernel, adding on top the Android, and then the Java or the application layer. And then based on all that, which is more or less shared, they add their strategic value and create their own product. This is, of course, possible in energy planning, and that's what we're trying to do within not only open energy transition, but in the open source space, including all the different organizations taking part in the Pipes Meets Earth initiative. So could you please maybe go to the next slide? That's, for me, something I would like to share with everyone here. I think it might not be very clear from the outside. How does governing a tool like Pipes to Earth happen? Of course, Pipes Meets Earth cover not only Pipes to Earth, our, let's say, big planning tool, but it covers many other tools as well. What I would like to quickly share idea on is how we manage this big one tool. There is an overall governance for Pipes to Earth main repository, and this is a public repository. If we press one more, Daniela, please. You will see that we have a group of maintainers. Who are these maintainers at the moment? This is a shared effort between individuals who come from Open Energy Transition, University of Pisa, OTH Regensburg in Germany, and Fraunhofer IEG in Germany. But this is not bound to only these 4 organizations. This is the status quo, but also your organization could be a part of that. How so? This is often done by meritocracy. So it's all about performance over time. One could usually start as a user of the tool, but then after some time, he gets hands-on experience, start contributing to the tool. And then over time, as he contributes a lot, we then this person could easily become a maintainer of the tool and then share this responsibility between even a 5th organization. Usually this is something that we share the decisions on, so responsibility, it's shared between the 4 institutions, and usually for big decisions happen by voting. Can you press one more, Daniela? Maybe press all of them until the full screen is there. But maybe, yeah, that's okay. But this is just the main Pipes to Earth upstream. We at OET have a soft fork of that. So we manage our own soft fork. We have our own governance inside the company. And this is something that we keep as a soft fork, meaning that we always keep this up to date with upstream so that we not only benefit from the new innovations happening in Pipes-Earth main repository, but we also contribute back. And that's the part of open collaboration that we are trying to advocate here. One more soft fork, for example, is Pipes ASEAN, now being led by Open Energy Transition and Rainer Lemoine Institute. That's also one soft fork, and it has its own governance, and these maintainers of the tool would then vote on what to go in, what not, and so on, specific to their case. These two are public, but that doesn't have to be the case. Some TSOs also could have their own version, another fork of Pipes-Earth specific to their needs, and they could also keep it private. It's not that we're saying open source has to be open for all applications, but there are institutions that would like to keep their own developments private, especially institutes like transmission system operators. If you go just one click, Danielle. The good thing is here, usually with this, there are support being offered by the I would say that the main developers of these tools. So for example, at OET, we do offer that, but if you're a company and you'd like to use this open source, you have many vendors to get support from. So not only OET, but any other company that has the expertise for maintaining and contributing to such tool, you can get support from, and you're no longer locked to the vendor of the tool, which would be the case in the proprietary tool case. And then the different softworks can always share features and speed up innovation, as we said before. Can we go to the next slide, Danielle? And here I just try to flesh out all the differences that I've seen between open source solutions and proprietary. You'll probably see me that I'm a bit more biased towards open source solutions, but I'm happy to hear other opinions. But this is the main things we've seen over the past few years. The ones I would like to highlight is, for example, transparency. This is something that we've seen, especially in Europe, many countries go more towards transparency, which helps advocate the case of open source. The vendor lock-in part, which is something I think I already highlighted. And then there's maybe the security part. So when we say that open source means that anyone can see the code, that's true. But we, in many cases, have seen institutions who are a bit resistant to the idea because they think that this means that all their data will be public, but that's not the case. With open source, you can have the methodology open, anyone can check it just to show how the results are derived, but you always have the option to keep your data secured and private, and you don't have to share it with anyone. These usually happen by creating new data pipelines that feed in your secure data or your private data securely to the open source software. Can we go to the next slide? Yeah, finally, just quickly highlighting what are the challenges of open source. It's not all good, and it's, of course, at least to me, the better option, but that means that it also comes with challenges. One is usually data gaps and data quality issues, and for that, we always try to have initiatives that focus mainly on data. For once, we have the Map Your Grid initiative that works on enhancing the transmission grid data that is more or less the backbone of all the energy studies that we do. For example, high technical complexity, because open source is usually not as easy to use as proprietary tools. And for that, we always try to give trainings. One is coming soon. I'll be sharing about this later today, to lower the barrier going into open source using like use and collaboration. Sustainability of maintenance, because again, like open source has this myth that it could die out after some time. And the way we always tackle this is to share this responsibility between many institutions, as we try to do in the Pipes Earth maintenance, now 4 institutions, hopefully more in the future. Tool fragmentation is basically because some people already use some, or like one tool is good for one application, but maybe you need more than just one application. So we try to make more tools interoperable so that data pipelines are easily connecting these tools. Institutional caution is more about just institutions are sometimes still lacking confidence in open source. But the more time goes on and the more projects or successful projects taking place with open source, we see lower boundaries to adopting open source tools and energy planning on the industrial cases. Yeah, and finally, it's just the integration with existing workflows, because usually institutions have their own energy planning ecosystem going on, right? It's not that they start from scratch. This happens, but rarely is the case. So there's usually a lot of challenging points in which it takes time for these institutions to move from their own existing, probably for years, workflows to new open source ones, even if it gives them more transparency and cuts them cost. I think that's the last slide, or maybe you can go next. Yeah, and these are just the two questions that I have for you. Maybe I quickly read them out and we can discuss them after Anna's presentation. One, I'd be really interested to know what would make your organization comfortable or more comfortable, if they already are, in collaborating. Like, what would make them comfortable to collaborate in these shared open source ecosystem? And question two is, to you personally, what would make you consider contributing back to the open source foundation and not only using the tools? Thank you so much. I hope I am on time, Daniela.
Yes, yes. Thank you, Hazem.